Probability examples 4 through 6. Alright, in this particular video, we are going to talk about the range of possibilities for probability, as far as what answers would seem reasonable. Now, you notice in the first few examples that we always got some sort of fraction that was less than 1. So with example 4 and 5, we're going to come up with a generality where we can pretty much predict where our probability values will lie. All right, example 4. You roll a standard 6-sided die. What's the probability that you will roll an 8? Well, as you know, a standard 6-sided die has 1, 2, 3, 4, 5, and 6 on it. There is no 8 on the standard 6-sided die. So that probability is 0 out of 6, which gives us 0. Now I think you could probably figure out that that's the lowest that the probability can be. You draw a card from a standard deck of 52 cards. What's the probability you draw a red club? Well, there is no red club. Our clubs are black, okay, in a standard deck. Okay, so red club, 0 out of 52. Again, that's 0. So our conclusion is the probability of an impossible event is always going to be 0. All right, well, that's our lower bound. Let's see what we can figure out about our upper bound there. It says you roll a standard 6-sided die. What's the probability that you roll a number less than 8? Well, all the faces of a die, 1, 2, 3, 4, 5, 6, those are all numbers less than 8. So all of them will fall in that category, are considered favorable. So we get 6 out of 6, and that reduces to 1. You enter a raffle ticket in which all the raffle tickets start with the number 875 and are red. What's the probability that the winning ticket starts with the number 875? Well, in this case, I don't really know how many raffle tickets that were issued, but if that is conditioned that they all start with the number 875, we know for sure that the winning ticket will start with 875. So the probability of a certain event is 1. So based on our answers to examples of 4 and 5 rather, we can now say that the probability of any event is between 0 and 1 inclusive. Okay, so on an exam, if you end up with a probability that's greater than 1, just take a moment and look at that, and well, you're wrong, because there's no way that can happen. And then try again. Be persistent. You can do it. Okay, complementary events. The complement of an event E is the event that E does not happen. Okay, think it through. This would be like we kind of talked about this in set theory. It's everything but, in that case, the particular set. So in this case, we want the probability of everything but that event happening. So we are going to use the notation E raised to a superscript C to represent the complement of event. So there are other notations. So if you look on my open math and you see this notation or this notation, those also mean complement. And my open math is fairly new for us, so I'm sure as time passes we'll get rid of any kind of notation other than what we've been talking about. But until now, you need to know those other notations. So the probability of the event happening and the event not happening is going to be 1. All right, so what can we do with that? Well, that means that if I wanted to figure out the probability of an event not happening, just using some algebra here, can you see I would take 1 minus the probability of the event happening? Full disclosure here, this particular formula is going to be more useful for us later on. For example, when I look at examples 6, A and B, I'm not really sure I need to go through all that trouble to find my answers. I can go a more direct route, but there are going to be some problems at the end of this unit that you are going to want this particular formula. All right, enough about that. Let's look at example 6. What is the probability you roll a standard 6-sided die and you don't roll a 3? Well, the more direct route here is that means I'm rolling a 1, 2, not a 3, 4, 5, 6. So the probability of not a 3, okay, well, that gives me 5 favorable outcomes out of a total 6. So I wanted to show you using the formula, probability of not a 3. Don't know why I superscripted that. 1 minus the probability of rolling a 3 will be 1 minus 1 6, which is 5 6. Okay, either way it works, doesn't it? All right, what's the probability you draw a single card from a standard deck of cards and you do not draw a heart? So not a heart. So I'll use a proper notation on that. Well, I could do 1 minus the probability of drawing a heart, which is 1 minus 13 out of 52. And that gives me 39 out of 52, which reduces to 3/4. And I'm sure you guys can understand that the direct way, well, how many cards are not hearts? Well, there's 39 of them that are not hearts. 39 out of 52 is 3/4. At this point, for problems such as these, I would be fine with either method.